Hello friends, this video on probability part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched probability part 1. Before we move further, let me introduce you to a new term called event. It is also a very crucial definition. It is nothing but set of favorable outcome. Set of favorable outcome. Favorable is a common keyword here. Also, if you notice, event is nothing but a subset of sample space. So when we have sample space, for example, we throw a dice 1, 2, 3, 4, 5, 6, then in that case you can have a event. I'll explain both things in details. Event can be odd number or even numbers of outcome. So this will be a sample space plus it should be favorable outcome. For example, this is the case when we are throwing a die. So sample space is 1, 2, 3, 4, 5 and 6. And now they are saying that I want all the event when number is greater than 4. So there are two numbers. So in this case, the event which we are talking about is 5 and 6. And if you see, E is the subset of S. Also, let's take one more event. When we say event is equal to all odd number in die. So all odd number, if you see, is 1, 3, 5. So this will be 1, 3, 5. And let me call this as event 2. Let's call this event 2. So event is nothing but a subset of set, plus it should follow a favorable outcome. In this case, the outcome was greater than 4. In this case, the outcome is all odd numbers. Let me take some more example of events. In this case, two dice are thrown. Find the event A and B. Event A is getting an even number on the first die. When I say two dice are thrown, die 1, die 2. This is the way it is thrown. And they are saying even number on the first die. So first die we can have 2, 4 or 6. Right? So when I have 2 in the first die and I throw the die again, the next die can get 1 or I can get 2 or I can get 3 or I can get 4 or I can get 5, I can get 6. Similarly, when 4 was thrown, in the next die I can get 1, 4, 2, I can get 3, I can get 4, I can get 5 or I can get 6. Similarly, when 6 was thrown, in the second set I can get 6, 1 or 2 or 3 or 4 or 5 or 6. So these are the events. These are the events A. Because here we are saying that the first is even number. If you see in all this case, the first is even. Now let's talk about B. B is saying sum of the number on the die is 6. So if you see, first number is 1, second number is 5. The sum is 6, right? 1, 5. Or if the first number is 2 and second number is 4, the sum is 6. If it is 3 and 3, it is 6. If it is 4 and 2, it is 6. It is 5 and 1, it is 6. So if you see, only these are the possible events. None other sample points belong to this. 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1. So these are events where the sum of number is 6. Now let's discuss types of events. There are three types of events. First is impossible and sure events. The second is simple events. And third is compound events. We'll discuss all these three. Let's discuss impossible and sure events. Impossible events will not have any event. For example, when I throw a die and I say the output is greater than 7. There is no number because when I throw a die, I get 1, 2, 3, 4, 5, 6 only. And I'm creating an event where the number is greater than 7. It's not possible. So the event will have 5. Sure event. Sure event is 100% sure and this will be a sample space. For example, when I throw a die and I say that the number is less than 7. This is number is greater than 7. And let's say this is number is less than 7. So number is less than 7 is 1, 2, 3, 4, 5, 6. Also, the number is greater than 0. So when you say this, this is exactly what you are getting. So it is the sure event. Also, when you say, when I toss a coin, I should get either head or a tail. That is 100% sure, because when you toss a coin, you'll either get head or tail. The example which I explained is rolling a die. When you say that I want the event for which the numbers are greater than 7, you get impossible, it's not possible, so you get 5. And when you say that I want an event for which n is greater than 0 and less than 7, all the elements come here. Try to understand here, if I say n is greater than 2 and less than 7, so this won't be a sure short event, because here 1 is not in the picture. What if 1 comes? 1 may come, which is not part of this event. So sure short event means all the elements should come. Then only it is sure short event. Okay. Now simple event. Simple event has only one sample point. For example, in rolling a die, when I say I want 3. So if you see 1, 2, 3, 4, 5, 6. This is the sample space. So if I say one event has only, event A has only 3. So this is a simple event. Or if I say, in this case, event B, where B is a multiple of 5, there is only one number that is multiple of 5, that is 5. So this is a simple event. The simple event will have only one element, compound element. So compound event will have more than one sample space. For example, when I say rolling a die, the sample space, as we all know, is 1, 2, 3, 4, 5, 6. And now I say event A is all odd numbers. This event will have 1, 3, 5. You see, there are multiple sample points. So this is compound events. So if I want to reiterate, this is 5, impossible event, 0 number. Then we have simple event, only one sample space. Then we have compound event, which will have n number of sample space. And then we'll have sure events, which will have S actually, all the elements. Generally, first and last are combined together because it is 0 or 1. So, but actually there are 4 kind of events. Now let's talk about algebra of events, because we have events, we have learned events. Why? Because we want to perform something on events. So there are a lot of things which we can perform on events. We can perform complementary operation on events. We can say event A or B. We can say event A and B. And we can say event A not B. These are some of the operations which we can perform on events. Let's discuss the first one. Complementary of event. Complementary of event means not A. To discuss with Venn diagram, let's say A is die odd number. So odd number is 1, 3, 5. So other points are 2, 4, 6 will be here, because this whole consists of universal set. So when I say A is equal to 1, 3, 5, complementary of A is equal to U minus A, and this is equal to 2, 4, 6. So if this is A, 1, 3, 5, this is complementary of A. Sorry. This is not A. This is complementary of A. This guy is not included in A. Similarly, when we say A or B, so A or B is A union B. So if example, A has the element all numbers greater than 4 in a die, n is greater. We are talking about a die now. Number greater than or equal to 4. A is equal to this, and B equals to number less than equal to 4. So now A is equal to 4, 5, 6, and B will be 1, 2, 3, 4. Let's put this in Venn diagram. Common, A is equal to 4, 5, 6, B is equal to 1, 2. See, B is equal to 1, 2, 3, 4, A is equal to 4, 5, 6. Now we are talking about A or B. We are talking about the whole thing which A and B has. So this guy denotes A or B. So A or B in our case will be 1, 2, 3, 4, 5, 6. The whole set. Now let's talk about event A and B. Let's take the same example where A is equal to n less than 4, less than equal to 4. B is equal to n greater than equal to 4. So A will have 1, 2, 3, 4 and B will have 4, 5, 6. Let's draw in Venn diagram. 4 is common, B is 4, 5, 6 and this is 1, 2, 3. Now when you're talking about A and B, this we are talking about the common element between A and B, and that is in our example 4. So A and B, A is A intersection B. Similarly A but not B. Let's take the same scenario wherein A is equal to n greater than equal to 4 and B is equal to n less than equal to 4. Here also we are talking about die. So A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6. Let's represent this here. 4, 5, 6. B is common, so we have put here, and 1, 2, 3. Now when I say A minus B, I want to say all the part of A which is not there in B. So this is A minus B. So if you see, right, we are taking A and then we are subtracting part which is common to A and B. Here A minus B is equal to 1, 2, 3. Similarly, if you want to do B minus A, so we will take all part of B and we will subtract part of B which is common to A. So this is B and we will subtract this. So what we will get, let me draw like this line, horizontal line. So this is B minus A. So B minus A in our case will be 5, comma. Before we discuss further, let me introduce you to a new term, mutual exclusive event or mutual exclusive set. So event A and B are mutual exclusive if the occurrence of any one of them excludes occurrence of other event. For example, they won't touch each other. When we say A is equal to even outcome is 2, 4, 6 in a die throw, and B is equal to odd outcome in a die throw 1, 3, 5. You represent in set diagram, it is 1, 3, 5 and it is 2, 4, 6. There is no common element. That means occurrence of A and occurrence of B are independent. Such kind of event is called mutually exclusive event. So if two events, if we draw the Venn diagram and they are not intersecting, that means they are independent, mutually exclusive. Now let's talk about exhaustive events. Lots of events that together forms a sample space called exhaustive event. For example, the same question, A is equal to, in a die thrown, A is equal to event outcome 2, 4, 6 and B is equal to odd outcome 1, 3, 5. If this is the case, let me put a bracket here. If this is the case, when you add A and B, you get what you get. If you say A and B, what you get is 1, 2, 3, 4, 5, 6. And this is nothing but total sample spaces. This kind of event called exhaustive event. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more.